I'm Kim Jake Tiani. Welcome to Cooler Facts, the show that's full of surprising facts about the world around us, science, nature, and technology. Now, the first fact you need to know is that this show has a bit of a different look. Get ready for a fun, fast-paced tour of short computer-animated bits. Each one will leave you looking at the world in a brand new way. Today, have you ever wondered how fast Mach 1 is? You'll meet a sea creature that's over 400 years old and an earthquake so powerful it caused a river to flow backwards. But first, we all know that the Olympics is all about the athletes and Olympic spirit, but what about all that technology?
What with the pressure of all the eyeballs on Earth watching Olympic athletes compete, the Summer Games often push the limits of building and engineering technology. Check out the Sydney Stadium that was built for the 2000 Olympics. At maximum capacity, it seats 115,000 spectators. If for some crazy reason you wanted to stack those chairs, the pile would be almost 69 kilometers high, more than 7 times the height of Mount Everest. Wow! Even keeping the Olympic torches lit was a technological achievement. There were 11,500 of them at the 2000 Games, which used a total of 922 kilograms of gas. That's the same amount of propane as 85 gas barbecues. The runners carried the original flame from its origins at Olympia, Greece to Sydney Stadium, a journey of 27,000 kilometers, more than half the circumference of the Earth. The highlight of building sophistication is Beijing's National Swim Center, nicknamed the Water Cube. The cube is made of a steel frame shaped like giant soap bubbles covered with a transparent super lightweight Teflon shell. The result is energy efficient. 90% of the solar energy falling on the building is trapped within the structure and heats the pools and the interior. The pool is wired with monitors that detect the winner by less than 1/100th of a second difference. The naked eye can't help spot the leader. A human blink takes 3/10ths of a second. There are sensors embedded inside the starting blocks and underwater touchpads at the end of the lane. The touchpads are ridged to ensure the swimmer's fingertip, not the force of the water the swimmer is displacing, trips the sensor. The sensors are backed up by cameras that take 100 pictures a second. There's seeing, and then there's tracking. Starting in 2000, marathon runners wore microchips tied to the laces of their shoes. Every 7 kilometers, the runners passed by an antenna that recorded their distance and speed. In fact, the longest race of the Olympics may be more exhausting than you think. The original marathon was set at exactly 26 miles, but during the London Olympics of 1908, organizers decided that the royal family needed a better view of the finish line. They added an extra 385 yards to the race so the finish line would be in front of the royal box. And it's been 26 miles and 385 yards long ever since. 42.195 kilometers. It's unlikely the Olympics will ever move the finish line again for a single person. Too many eyes will be watching. The Beijing Games in 2008 are expected to attract 1 billion people. That's 1/6 of the planet.
Watching those athletes break all those records is probably the best entertainment around. Breaking records, well, that's the focus of our next Cooler Fact. Breaking the sound barrier. Welcome to a world where a piece of dirt can weigh as much as an elephant.
Ever since we humans have been upright and walking, there has been an eternal quest to be the fastest human on Earth. The Holy Grail is traveling at Mach 1, faster than the speed of sound, just over 1,200 kilometers per hour. That's more than 300 meters per second, roughly 10 times the speed of tennis great Roger Federer's serve. At that speed, you could drive to the moon in about 2 weeks. The place to attempt to go Mach 1 is here, in Nevada's Black Rock Desert. With a surface as smooth as a tabletop, it's the heart of land speed racing. This is where in 1965, Craig Breedlove broke a 960 km/h speed barrier in his Spirit of America, a 3-wheeler powered by a J-47 jet engine. Going Mach 1 in an airplane isn't nearly as dangerous. On the ground, shock waves can launch a vehicle airborne. Traveling that fast, a piece of dirt the size of a quarter and stuck to the wheel rim weighs as much as 700 kilos. Years later, in 1996, Breedlove tried again. He was aiming for a 1,000 km/h cruising speed, and his speedometer rose close to 1,300 km, faster than any car had ever attempted to go. Suddenly, a wicked crosswind struck him, jacking the car up on its forward and side wheels. The wheels acted like a giant off-kilter gyroscope, forcing the vehicle off course. Breedlove was hurtling blind, but he kept his cool and was able to walk away. The good news, he broke the sound barrier. The bad news, it didn't count. Land speed rules require drivers to make the 1.7K run twice. In 1997, Royal Air Force pilot Andy Green stole Breedlove's thunder. He hit the elusive Mach 1 mark in this, his Thrust SSC. It's powered by 2 Rolls-Royce jet engines, producing a total of 100,000 pounds of thrust. That's the power of 1,000 Ford Escorts, or a 747 at cruising altitude. Breedlove's dreams of breaking the sound barrier again went up in smoke. He ran out of money and energy. Attempting to break the land speed record takes genius, courage, and determination. But actually going transonic is somewhere in the realm of the miraculous.
Looks like breaking Mach 1 is going to be one tough record indeed. Coming up, the location of one of the world's biggest garbage dumps, and you'd never guess where it is. Hey, welcome back to Cooler Facts. I'm Kim Jake Tiani. Now, nothing turns you into a recycling enthusiast like seeing a huge pile of garbage, especially if it's in the middle of nature. Here's one that's waterlogged and as heavy as 17 aircraft carriers.
The calming blue serenity of the Pacific Ocean. But look under the surface. Welcome to the giant toilet bowl of plastic. About 1,000 kilometers north of Hawaii, in the Pacific Ocean, floats a mass of plastic garbage that is so big, it has an area twice the size of Texas. Its nickname is the Eastern Garbage Patch, and it never disappears. The garbage gets trapped there because of an ocean phenomenon called the North Pacific Subtropical Gyre. A combination of high-pressure air and clockwise water currents ensnares garbage that floats in and won't let it out. Based on 2007 water samples, there's an estimated 6 kilograms of plastic for every kilogram of naturally occurring plankton trapped in the patch. And there are similar trash traps in other oceans, in the South Pacific, the North and South Atlantic, and the Indian Ocean. We produce around 100 million tons of plastic each year. 10% of it ends up in the sea, and it gets into everything. Plastic sheeting has been discovered in the stomachs of sperm whales. Dutch researchers dissected a seabird that contained over 1,600 pieces of plastic. The problem is that plastic is bio-inert. The durability and stability that makes plastics so useful to consumers also makes them a problem in marine environments. Plastic only breaks down into fragments that end up in the food chain, to be eaten by seabirds and marine life. It gets worse. Not all plastic floats. Around 70% of plastic discarded at sea sinks to the bottom, creating a garbage dump on the sea floor. In the North Sea, Dutch scientists counted around 110 pieces of litter for every square kilometer of seabed. 600,000 tons in the North Sea alone. That's the weight of 17 aircraft carriers. In addition to plastic garbage, industrial runoff like fertilizers or sewage that flow into the coastal regions makes the ocean even more of a deadly garbage dump. The technical term is creeping dead zones. That's what happens when pollution causes the water at the sea floor to become anoxic, meaning it contains almost no dissolved oxygen. What happens is garbage chemicals cause coastal algae to bloom to excess, and they produce oxygen. In response, seafloor bacteria consume all of it and exhaust the dissolved oxygen in the water. It kills the environment for other marine life. One of the most extreme dead zones is in the Gulf of Mexico, where the Mississippi River releases high volumes of fertilizers from the U.S. agricultural heartlands. Another strange item in the ocean's garbage dump is junk that has fallen from space. In 2006, the Russian Progress M56 cargo ship removed old equipment from the International Space Station. Most of the ship and load burned up during re-entry, but surviving fragments fell into the Central Pacific. Called the Spaceship Graveyard, it's the same spot where bits of the Mir space station fell in 2000. In theory, magnets could find and retrieve the spaceship's metal fragments, but there's no effective method to collect floating plastic. It may be a long time before we unclog this giant toilet and return it to a more pristine blue.
Let's hope for a return to that pristine blue. Fortunately, it's not all bad news when it comes to the ocean, especially if you go deep.
One of the greatest mysteries on Earth lies at the bottom of the ocean. In fact, it is the bottom of the ocean. The pitch-black depths of the ocean remain one of the final frontiers. Would you believe there are more maps of the moon than there are of the deep ocean? We've explored only 0.0001% of the deep ocean floor. In 1960, just off the coast of the Philippines, the U.S. Navy used a French sub, the Trieste, to be the first to reach the deepest point of the Pacific Ocean, the Challenger Deep, located in the Marianas Trench. This point of the trench is 11 kilometers deep. That's over 1,400 meters deeper than Mount Everest is tall. These deep waters can expose the ocean to the hot interior of the Earth. In 1977, scientists discovered hot springs jetting out of the ocean floor off the Galapagos Islands. Down 2.5 kilometers, these underwater smokestacks spew burning hot fluids full of minerals. But despite the heat, the water doesn't boil. That's because the weight of the ocean creates such a pressure that it raises the water's boiling point above 380 degrees Celsius. Amazingly, the pitch-dark hot waters are teeming with sea life, such as giant tube worms, lanternfish, pink sea urchins, and spider crabs. These life forms survive by a process called chemosynthesis. They have a way of converting carbon molecules into organic matter. New imaging technology is also revealing how sea life behaves down deep. After 3 years of trying, Japanese biologists finally hooked an elusive giant squid with an underwater video camera in 2005. It was swimming 900 meters below the surface. Before this footage, no one had ever seen a live giant squid swimming in the ocean, so far beyond the range of sunlight. These beasts have only been netted before or have washed up on beaches. And by giant, we're talking big. Giant squids can weigh up to 1,000 kilograms. The largest ever spotted measured a vast 18.5 meters and was found in 1880 off Island Bay in New Zealand. That's the length of 2 buses, but only the weight of a compact car. Every day, the oceans turn up a new clue as to what life is like on the ocean bottom. Scientists think that a clam recently dredged up off the coast of Iceland may be the longest-lived creature ever discovered. By counting rings on its shell, researchers calculated its age at between 405 and 410 years old. This clam was holding court at the time of Queen Elizabeth I and Shakespeare. The previous record age for a clam had maxed out at 220 years. Commonly known as the ocean quahog, the clam's super slow rate of cellular decay may provide clues to the secrets of longer life. We've only scratched the surface of what lies on the deep ocean floor. Who knows what more we'll find in the underwater world of our own planet.
Stay tuned. Even more cooler facts heading your way right after this break. Welcome back to Cooler Facts, the show that sheds light on science and nature by giving you tons of takeaway facts. Now here's a good one. What do you get when you cross a jellyfish with a pig? A piggy fish? A jelly pig? I don't know, but I do know it's just one of many creatures that glows in the dark.
Fireflies lighting up the evening sky are dazzling. Yet in nature, bioluminescence, the ability to glow in the dark, is more the rule than the exception. If you dragged a net in any part of the world's oceans, from a few hundred meters to the surface, almost 90% of the creatures you'd catch would be bioluminescent. Not only that, animals that glow travel in unimaginably large numbers, like the krill. This glow-in-the-dark crustacean is likely the most populous animal on Earth. It swarms in the waters of Antarctica in mobs of 2 million tons per 500 square kilometers. Krill are so prolific, biologists estimate their combined weight is greater than the human population of the world. Animals light up for very expected reasons: to find food, attract mates, and defend against predators. Question is, how do they light up? Bioluminescence is a chemical reaction that results in light without heat. It happens when a protein called luciferin comes together with the enzyme luciferase. Throw oxygen into the mix and you get oxyluciferin, a molecule-sized lantern. It's a favorite party trick of the jellyfish. Of all the jellyfish species, about half are bioluminescent. The most spectacular among them is this feathery, flamboyant creature, the siphonophore. Not only does it glow a fiery red, when under assault, it releases thousands of glowing particles, ones that mimic small plankton that confuse the attacker. Actually, the glow bestowed by nature isn't just pretty. It's lighting up the path to life-saving new discoveries. Which is why in 2006, researchers in Taiwan bred these bioluminescent pigs, created by adding genetic material from jellyfish to a pig embryo. Even their hearts and internal organs are fluorescent. These pigs were bred to study human disease. When the pig's stem cells are injected into another animal, scientists can track the progress of the cells without invasive surgery. Some plants are bioluminescent, including a species of mushroom called Omphallotus nidiformis, or ghost mushroom. It looks a lot like the oyster mushroom, but you don't want to confuse the two. Ghost fungus are toxic, which is a shame. If they were edible, along with glowing lakes, tides, sea creatures, and flies, we'd have neon soups and omelets. Now that would be cool.
Coming up right after the break, a natural disaster so big it shook Earth off its axis. Hi, welcome back to Cooler Facts. Scientists have spent a lot of time building bombs and creating chemical explosions. But the truth is, Mother Nature packs the greatest punch. In fact, her secret recipe of tectonic plates and molten lava takes the cake.
It's easy to take the solid ground for granted until the odd rumble reminds us just how much power the Earth can unleash. One of the most bizarre results of an earthquake happened in 1811 in the state of Missouri. The magnitude 8 quake lifted up the land so high that it created a dam, causing part of the Mississippi River to temporarily flow backwards. Quakes measuring over 8 on the Richter scale happen on average about once a year. They release the same punch as a 1 gigaton bomb, or 5,000 times the size of the bomb dropped on Nagasaki at the end of World War II. So where does all that energy come from? Well, the Earth is like a pressure cooker, a hard external crust that floats over layers of molten hot rock or magma, ending with a solid rock core under intense pressure and heat. Geologists recently discovered that the solid iron core is actually revolving slightly faster than the surface of the Earth. It's like a planet within a planet. Over 120 years, the core completes one extra rotation. The surface of the Earth consists of large, brittle, 100-kilometer thick tectonic plates. The heat inside the Earth causes the plates to slowly but constantly move. Their collisions create seismic waves or ground vibrations, so powerful that they rip apart the Earth's crust. In 1935, physicist Charles Richter developed a method to measure and compare the magnitude of earthquakes, inventing the Richter scale. Going a whole number higher on the Richter scale is a 10-fold increase in the strength of the seismic vibrations. So while an 8 is strong, remember what a 9.1 can do. In 2004, off the coast of Indonesia, under the sea, a whopping 9.1 strength earthquake hit. It was so big that it shook the Earth off its axis by 1 centimeter and caused ripple vibrations as far away as Alaska. Back at the epicenter, the force of the earthquake caused a tsunami. It displaced a huge tabletop of ocean water. That's what set up the massive waves. In deep water, a tsunami's 30-meter waves can travel 800 kilometers per hour. That's like a 9-story building moving faster than a Learjet. All this natural fury is because of that pressure cooker of molten rock that sometimes blows in the form of a volcanic eruption. Molten rock or magma from as far below as 500 kilometers inside the Earth can seep up through cracks between tectonic plates, building up a mountain of rock. It then spews a volcano. Iceland is the largest volcanic island. Its entire surface was formed by eruptions from the mid-Atlantic ridge of volcanoes. Back in 1783, the Laki volcano erupted with a flood of lava that was 30 meters deep and 80 kilometers long. The worst volcanic eruption happened back in 1815, when Mount Tambora in Indonesia blew out 50 cubic kilometers of magma. It covered 500,000 kilometers of land and sea with 1 centimeter of ash. That's an area the size of Spain. In 1883, the volcano Krakatoa put so much dust into the Earth's atmosphere that sunsets appeared green and the moon appeared blue for almost 2 years. Turns out the tiny 1-micron ash particles scattered red light, but would allow other colors to pass. So the white moonlight shone through the clouds and appeared blue and sometimes green. Nothing stays still for long on this planet. Constantly shifting tectonic plates and the hot liquid core guarantee that there is no such thing as solid ground on this surface we call home.
Well, hopefully we won't be seeing any green sunsets or blue moons anytime soon. But we will be seeing another episode of Cooler Facts. We'll have submarines with swimming pools on them and everything you didn't know about space junk. All done up with our animated twist. Thanks for watching today. I'm Kim J. Kiani.